Okay, so today we're going to do a quick review on multiplying fractions, and then we're going to also talk about the quantitating one, or the magic one, which we've used several times when trying to find like denominators, but we haven't quite explained yet. So I want to make sure that we understand what the magic one is and how we're going to be using it. Just to review, in terms of multiplying fractions, these are really great ways to illustrate this concept. So I'm going to look at this example, which is 5/6 times 1/2. And I'm going to draw in what my fractions are. So I have 5/6 and 1/2. Now, if you're going to illustrate this on your own, it's really important to use various colors and also to change the direction of the lines that you're using to create the fraction. And you'll be able to see this when I further illustrate the concept, okay? So what we know mathematically is that 5/6 times 1/2 means I'm multiplying my numerators together and I'm multiplying my denominators together. So 5 times 1 is 5. 6 times 2 is 12. So my solution should be 5/12. Now let's use our picture and double check. I'm just taking the 5/6 that I drew in my first square and shifting them over to my second square. And the reason I'm doing that is because I'm going to figure out how many of the 5/6 are represented in the 1/2 of my other square. So you can go ahead and double check your denominator by counting up the total number of pieces in your new square. And I have 9, 10, 11, 12. Clearly, I have 12 pieces in my new square, which checks off my denominator of 12. Now I need to know how many pieces existed in the original 1/2 and in the original 5/6. And you can see that by where those two colors that I used, the pink and the yellow, overlap. So that's why this is important. So I have 1, 2, 3, 4, 5 sections here that are overlapping, and that is my numerator of 5. So I've just confirmed that I have the right answer for 5/6 times 1/2, and that is equal to 5/12. Now, the reason that's important for us to think about is when we're talking about multiplying fractions, that we're always multiplying numerator times numerator and denominator times denominator. And that gives us our new numerator and our new denominator for our fractions straight across. This is important because we're going to be using the quantifying one to manipulate our fractions, to make them different. And one way, or one reason we need to manipulate fractions is to make sure we're finding common denominators. So, for instance, when we're talking about adding and subtracting, so why do we manipulate? When we're adding or subtracting unlike denominators, right? We need them to be alike. So we use the quantifying one, or the magic one, to make denominators alike. What we're also going to be using the magic one for is to make denominators a power of 10. And a power of 10 is equal to 10, 100, 1,000, and so on, right? All those numbers, 10,000, 100,000, a million, as we just keep going up and up and up. And this is important when we start to change fractions to decimals. We're going to need that. Fractions to decimals, right? So let's look at the example that I have in here for us. What fraction part of this hexagon is red? Well, I have 1, 2, 3, 4, 6 red pieces. So what we're saying is all of the hexagon is red. But my answer is not a fraction. So what I need to say is 6 pieces out of 6 pieces are red. So that is 6/6. And so this is a whole hexagon. It's equal to 1. This helps us represent that when a numerator equals the denominator, it's the magic 1. That means I have a 1. Why is a 1 so important? Well, a 1 is the identity in multiplication. And what that means is that no matter what number I multiply by 1, it always keeps its true value, its true identity, right? We know this. This is just the correct terminology in saying it. So 1 times 5 equals 5. 1 times 20 equals 20, right? All of these kinds of examples. 1 times 27 equals 27. The 1 doesn't change the identity of my number, so that's why we call it the identity. And a 1 can be used in fractions to manipulate. It doesn't change the value, but it can, in fact, change the denominator. So, for example, if I needed the fraction 3, 3/5, right? And I needed that to have a power of 10 as a denominator. How can I change it from 3/5 to be something over 10? Well, I use my magic 1. 3/5 times what number will equal 10? Well, hopefully, you know that 5 times 2 equals 10. So all I have to do is fill in the 2 in my numerator to do 3 times 2 equals 6. And now I have an equal fraction to 3/5, but that has a power of 10 in my denominator. And this is really important when we start talking about decimals. So this kind of manipulation of fractions is going to be really important and really useful for us as we move forward in this unit.